Hello everyone, welcome to project number 13, and here you will deal with server log analysis. This is a very common use case that you'll find in various organizations. It is part of observability and monitoring. So before doing monitoring, there has to be some analysis also, or some analytics that has to be run on the data which are generated by various servers. And that is what you are going to do. It is a very simple project that you have to execute as opposed to the previous two. Previous two, I think, were pretty comprehensive and complex, but this is going to be pretty simple. The combined dataset size would be 54 GB, and that is the uncompressed size. And these are the different files. We have client machines, front end and back end server information, database server information. There's some front end and back end server details and database queries details. I don't think client machines have to be used. I do not have any problem statements wherein you'll have to use the client machines data. I'm not sure why did I create this. If you want, you can play around with client machines data also. For front end and back end servers, the file names are server CPU memory disk data number 1 to number 8.csv, because there are 8 files, and these are the columns that you'll find in these files. Similarly, you have database server data. You'll find 8 files for database servers. The name would be database CPU memory disk data from 1 to 8, and these are the various columns. Then we have server details data. There is only one file. It contains the information about the IP address of the server, what server type is, what is the server environment. Server type will mention whether it is a database server or application server or front-end server, etc. Server environment will tell you whether it is a POC server, a staging server, production server, and so on. Finally, we have database queries files. The name would be database query data from 1 to 8. There are 8 files, and these are the information that you'll get. For example, the query timestamp, the database server IP, the query ID, database name, query type, whether it is select query, update query, insert, or delete query. Then the execution time would be in milliseconds, the number of rows returned and number of rows read. The number of rows read would be relevant for select, update, and delete, and number of rows returned would be only relevant for the select queries. Similarly, number of rows updated would be relevant for update queries, rows inserted would be for insert queries, and rows deleted would be for delete queries. Then we have index use flag. This is relevant for select, update, and delete queries, not for insert queries. Then you have read IO information and write IO information. What is the number of IO operations that have happened on the disk? For each query timestamp, you'll find events timestamp also, which would contain CPU information. What is the CPU user percentage? What is the CPU system percentage, idle percentage, wait percentage? If you see that some rows contain minus value or negative value, you would know that this is part of virtual server. Then you have total number of CPU cores, total memory GB, the available swap used, etc. Similar information would be there for front-end and back-end servers also. So these servers or the data in these files would be used for monitoring. Now there can be two types of monitoring. One is the reactive monitoring and the other one is proactive monitoring, or we can call it as proactive or historical monitoring also. Now in this case, what happens, let's say you have various different servers. You have client machine, front-end server, back-end server, database server. The client machine can run technologies like Java application, front-end applications, command line interface, which can connect to the database directly, or they can connect to the front-end server also, and front-end server would connect to back-end server, which will in turn connect to the database server. Now all these servers will generate their own resource utilization matrix. For example, front-end server will have its own resource utilization matrix, so would have the backend and database servers. Now these resource utilization matrix are sent to a centralized log server. Now when I say centralized log server, it can be a distributed file system or can be a database also. Typically it is a file system because it does not make sense to store so much of log data in a database. That's why it would be a file server typically. Typically, the central log server would contain all the resource utilization metrics or data points in files. And from there, we have to do various aggregations and analysis, and then we put it in monitoring servers like Grafana, Prometheus. Now here, whenever we store the data, it is typically stored in databases because the monitoring team has to create dashboard from the Grafana or Prometheus server, and the Grafana and Prometheus server or any other observability tools that you can think of, let's say OpenTelemetry, etc., would contain these aggregated data in database servers, and from there the dashboards are created which are eventually visualized. So this is the proactive monitoring, wherein we look at how the server utilization has been, how the database utilization has been, how the CPU, memory, disk utilization of different servers. And based on that, we can take a decision whether we have to add more servers, remove servers, etc. And this is how the architecture of the implementation would be. This is what you will implement. Because you do not have any front end, back end, or database server for that matter, I have created the files. And you can assume that the files have been stored in central log server. Whatever files I provide, you have to upload it in S3 and then pull them, do the transformation and aggregation, and store them in the transformation database, and then store it in Grafana Prometheus server database also. Of course, you do not have to create any Grafana or Prometheus server or visualization for that matter. Your job would be to pull the records or the files, log files from S3, do the transformation and aggregation as per the monitoring requirement, and store it in the database. Now, this database would be a MySQL database. You can use Aurora Serverless, or if you want, you can use RDS also. And there would be a separate database for Grafana, Prometheus, etc. In most of the cases, this would be a time series database like timescale DB. But here we'll not be using timescale DB because we are not bothered about this part. This would be something that is taken care of by the observability or the application team. We are bothered about this part only. And this is what the problem statements are for proactive monitoring. I'm considering Grafana reports. So the reports have to be in different time frames. Like it can be for 5 minutes, 1 hour, 24 hours, 1 week, 1 month, 3 months, and 6 months. And we'll have to get the CPU, memory, disk, and database query details, etc. for these different time periods. Question number 1, 2, 3 are the different problem statements. First, it asks you to find out the inventory of distribution of servers. And the requirement is to find out whether the distribution of prod server matches with the staging server or not. The reason they have to match the distribution because staging server is a pre-prod environment, and in most of the cases the staging environment is a replica of the prod environment. So this is one of the first requirements, that you have to find out the distribution of servers. Once that is done, then we have problem statement number 2, wherein for the years 2025 and 2026 you'll have to aggregate the data as per sub point number 1 and 2 in 2. So now these are needed for Grafana databases, and it wants you to find out the average and max CPU memory utilization for all servers over a period of 5 minutes to 6 months as mentioned above. So your time period should be 5 minutes, then 1 hour, then 24 hours. So you'll have to run mostly the same type of transformations, but the time period has to be different. You'll also have to find out the memory and CPU spikes for prod servers over 1 week and 1 month. In real life scenario, it is much lesser than 1 week. It is for a few hours to a week or to a month also. But here I have mentioned only 2 time periods. One is 1 week and the other one is 1 month. Then you have database server analysis. You can go through it. And these are the various different requirements. And as usual, all these requirements have to be handled by PySpark. So this is part of the proactive monitoring. Then you have reactive monitoring. Reactive monitoring is used for critical servers like database servers and application servers, like backend application servers, database servers, front-end application servers. And out of all these, database servers are the most critical for any application. So that's why we'll be doing the reactive monitoring for database server only. And the top part is something which happens in production environment. Let's say you have various different database servers wherein you run queries from backend applications or command line interfaces, and then the database server would generate query utilization reports or query utilization metrics and resource utilization metrics. Those are captured using API and then maybe sent to a Kafka topic, which goes to a stream processing and store it in a database so that it can be sent to a Grafana dashboard. And this is reactive monitoring, so that's why it has to be near real time. For this particular portion, for the database server and API, we are not using any database server or any API for that matter, because we have database server matrix file. And what you have to do is that you'll have to read from these files, use a Kafka producer application, and send it to the Kafka topic. And these portion would remain the same. You do not have to worry about the Grafana dashboard. You'll have to do the stream processing and store it in a database. It can be any database of your choice. And this is what the requirements are for the reactive monitoring. There are a few things. Query and resource monitoring has to be done for all query types. The select, update, delete, insert, and you'll have to read records from the files database query data 5.csv and database CPU memory disk data 5.csv onwards. Meaning you'll have to start reading from these two datasets. There are 8 datasets, so you'll have to start reading from here. And these are the requirements. Monitoring is for 15 minutes. It also tells you what is needed for monitoring, like the SLA for select queries, update and delete queries is 2 seconds. So you'll have to capture the queries whose execution time is more than that. Now, along with that, you'll have to find or capture other information also. Same would be for insert queries and update and delete queries also. In insert queries, you'll have to find out the CPU and IO usage. Point number 5 is the average CPU utilization that you have to find out for select, update, and delete queries when indexes are getting used. And all of the output for all these problem statements have to be saved in a MySQL database with all the above information so that it can be shown in the Grafana dashboard. I am asking you to store it in MySQL. If you are comfortable with some other database, you can use that also. But you have to store it. And what should be the schema? That has to be decided by you as a data engineer, because you know, based on the problem statements, how these data points should be shown in the Grafana dashboard. So that's why you will have to define the schema and then create the tables. So this is a very short and small project. This is also not very complex, but it will give you a sense of how observability is handled in big organizations and how Spark plays an important role in the observability or DevOps side also. Thank you so much.